Hello students. Today we will perform the experiment on measurement of ABCD constants of medium transmission line. This is the circuit diagram for this medium transmission line. This is the medium transmission line model on which we have to carry out open circuit and short circuit test. So first we have to give the supply to the sending gain, keeping receiving gain open. In order to measure corresponding voltage, current and power on the sending end side, we have connected voltmeter of 0 to 300 volt, ammeter of 0 to 100 milliampere and wattmeter of 300 volt 1 ampere low power factor. And in order to measure the voltage at receiving end, we are going to connect a voltmeter across receiving end. And then under short circuit condition, we will short the receiving end and we will give the supply to the sending end. The same open circuit and short circuit test we are going to repeat by exciting receiving end side, keeping sending end open and sending end short. Now I have done the connections for open circuit test. I will show you. This is the transmission line model. This is a medium transmission line model of 100 kilometer long. These two terminals, if you see, these are the sending end terminals, and these two terminals over here, we will treat this as the receiving end terminals. This is a pi section model, so capacitance is on either both sides, on sending end side as well as on receiving end side. Total line resistance and line inductance, they are lumped. Now if you see the circuit diagram, accordingly I will explain you first the connections for open circuit test. So if you see, we are giving the supply through the dimmer stack. So from auto transformer, the connection is going to the ammeter. So from auto transformer to ammeter, this red color wire. Then from ammeter to wattmeter M, see this. From auto transformer to ammeter, then from ammeter, this green color wire to wattmeter M. This wattmeter which we have selected is low power factor wattmeter. You can see here cos phi is written as 0.2. So to the wattmeter M over here. Then MC shorted and L is connected to the transmission line, this green color wire. Okay. And then transmission line back to the auto transformer, this red color wire. This one. Okay. And then V terminal of wattmeter, this we have selected 300 volt. So V terminal is connected to the base of transmission line. So written back. And in order to measure the voltage, the voltmeter is connected across the dimmer stack. So 300 volt and common. This wire. Okay. And receiving end is open circuited. So across the receiving end, again we have connected a voltmeter across these two terminals of 0 to 300 volts. Okay. Now this is the observation table. So there are four conditions. Receiving end open circuited. At that time we have to apply the rated voltage to the sending end. Corresponding value of sending end current and sending end power we have to note down. Then the receiving end short circuited. At that time we have to pass the rated current through the receiving end, which is of 1 ampere. Corresponding value of sending end voltage and power we have to note down. Then we have to make sending end open and sending end short. The corresponding values of receiving end current, receiving end power, or receiving end voltage and receiving end power we have to note down. Okay. So I will run the experiment now. We will switch on the supply. And then if you see in the voltmeter, we will apply 230 volt voltage. So middle scale we have selected. So 230 volt I have applied. Okay. And then we will note down the reading. For better reading of the voltage, we will measure the voltage with the help of DMM. So I will set the DMM to 300 volts, sorry, 750 volt, and then we will measure the voltage across sending end. We have set this to 230 volts. See, 230. Okay. And now we will note down the value of current. So see the ammeter. This, it is 83, right? One division of 1 milliampere. So current is 83 milliamperes. So let us write. And power is, that is low power factor. So the divisions are very less. It is 0.3, right? Pointer is at 0.3, and multiplying factor is series connections of the plate and 300 volt. If you see the refer the table, it is 1 ampere, which is for series connection, and 300 volt. So multiplying factor is 4. Okay. So 0.3 watt is the power, multiplied by 4 is MF. Okay, and at that time, now we will measure the corresponding value of receiving end voltage. If you see, the voltage at receiving end is 231 volts. So because of Ferranti effect, you will get that voltage as greater than sending end voltage. So I will write this receiving end voltage, which is 231 volts. Okay. Now what we have to do, I will reduce the voltage and switch off the supply. Now already the open circuit test connections are done, and hence what we are going to do is we will take the third reading in the observation first. So if you see the observation table, sending end open circuited, this reading we will take first, okay, as connections are already done. So what we will do, we will just interchange these two wires so that this bottom base is same, so no need to change these wires, just we will exchange these wires. So I will remove this and remove this wire. On this side I will connect it to the receiving end, and this wire which is connected previously to the receiving end, now I will connect it to the sending end. And now same experiment you have to repeat. Now these meters get connected on the receiving end side. Okay, so again I will switch on the supply, apply the voltage of rated voltage of 230 volts, and now let us adjust the correct value of voltage with the help of DMM. Two 30 we have adjusted. So let us take down the reading. If you see the ammeter, voltage is 230 volt, current is again 83 milliampere. So current is 83 milliampere, and power, if you see, again it is 0.3. Okay, so again power is 0.3 and multiplying factor is 4. Okay, receiving end voltage we will measure. So that is sending end voltage, not receiving end. So at this time we are getting the reading as 228. Okay. So sometimes we will not get the effect on the medium line, but we will get the effect on long transmission line. The Ferranti effect you can observe. Now I will reduce the voltage and I will switch off the supply. Now we will remove these connections and we will do the short circuit test connection, and we will take the reading for short circuit test. Thank you.